Please welcome Erik Michelsen.
Thanks for coming out tonight. The inspiration for my presentation was this painting by René Magritte, early 20th century French surrealist. The title is "This is not a pipe." The idea of the painting was to challenge the representational notion of objects. It was in fact a painting of a pipe rather than a pipe itself, but to get us to think along those lines. The idea of my presentation is that this is not a stream, this beautiful S-shaped sinuous form that we're so accustomed to thinking of when we think of waterways moving through the landscape is in fact the response of a water course to a heavy sediment load. And so this kind of form is actually a heavily impaired system. But the idea of this sediment load is, where did it come from? Over the course of the past 350 years, the forest throughout the Chesapeake Bay region has been cleared time and time again. In the South River watershed, the virgin forest was cleared by 1700. As you can imagine, as a result of that, there was a lot of loss of agricultural soils. This is a picture looking across the Severn River at the Naval Academy. You can see about 100 years ago, the forest was much less mature because it had been cleared over many times. There's actually probably less trees here 100 years ago than there are now. So the landscape that we see now is not what was here historically in a lot of different ways. The cutting edge research on this matter suggests that over the course of this past couple hundred years, between 1 meter and 3 meters of these legacy agricultural sediments have actually moved down into our stream valleys, which were broad, wide, shallow floodplains like this, swamps where the water was spread out across the landscape in a couple of inches. And in fact, that channel that we're so used to seeing now is the result of higher velocity and volumes of water moving through the systems, cutting down through those agricultural sediments. And so what we're left with is cases like this. This is up on Flat Creek on the South River, where you've got that 10 to 15 feet of those agricultural sediments that have been cut down through as a result of rain, and that material is actively transporting down to tidewater. It's a big source of pollution for both sediments and nutrients, and again, we're working in these artificially restricted systems. 2 of these pictures are of agricultural ditches, and then 2 of them are sort of what we would more conventionally refer to as streams, but in fact, they're all performing basically the same function. These are all heavily disturbed systems, and again, even what we've got is some of our archetypical notions of streams and these water courses are badly off, unfortunately. And so on the left, we have an actual agricultural ditch. On the right, we have a picture of Bacon Ridge Branch, which is one of the main freshwater tributaries to the South River. And they're basically the same situation. One has about 50 years of forest growth on it, but it's still contributing the same kinds of problems. And so what are some of the issues associated with that? One is, as these streams cut down through the landscape, they end up lowering groundwater tables, and we end up losing wetlands that are in the areas because the hydrology changes, and we end up draining those systems with base flow. The other, of course, is we've got the runoff, the silt that's coming from those systems is that material is shed during base flow and storm events. This is coming from the least developed portion of the South River watershed above Route 50 there, and you can see the water looks like chocolate milk as it moves down after a 2-inch rain event. So what are some of the solutions that we can do, or how can we reverse some of this damage? One is beaver reintroduction. We can either actively reintroduce beaver into the situation, or we can let the beaver moving themselves back in, and if we can just sort of eliminate the impulse to remove them, that's one way we can get there. Another is to actually, through restoration methods, raise the invert of those stream channels and put that water back on the landscape, create those wetlands that have been lost, and to get water broad, shallow, aquatic beds, and we really take the energy out of it from storm events. And then the other is one of the things that's going on in Pennsylvania is excavation or removal of these legacy agricultural sediments so that we can, again, get that same kind of form where we've got the water spread out broadly on the landscape, we've got great habitat, we've got great nutrient and sediment reduction, and we take that material out of the system so it's not being transported. So why do you all care about this? Well, this is a picture of Hispaniola. On the left, you've got Haiti. On the right, you've got the Dominican Republic. It's really sort of a very stark picture of proper versus improper land use and management of natural resources. As a result of poor lumber resource management in Haiti, you've actually got sediment running off the landscape, covering the coral reefs. This is the Caribbean, beautiful blue waters. Those reefs are dying off. Haiti is now where we were, say, 250 to 300 years ago when we had tremendous filter feeder resources, but now we've got all this activity going on in the water column. We've got sediment, we've got nutrients stirred up, we've got these algal blooms that shade out the underwater grasses and that smother our filter feeding organisms, and the next slide you'll see is actually, several hundred years ago, the Chesapeake had crystal clear water. We had our own set of reefs. We had oyster reefs that were abundant, that were all throughout the landscape. That we had aquatic grasses. We had other kinds of organisms filtering the water on a regular basis. But as a result of those historical land use patterns, that's been lost. My main point really is that the only way that we can get back to trying to achieve that goal is by taking some lessons from the past and trying to replicate the way the systems functioned historically and having a better understanding of how those systems functioned historically by putting water back on the landscape, mimicking those historical functions and allowing us to clean up the water that's going to our rivers in the Chesapeake Bay. So thank you all.